Right, so welcome to today's class. So in this class, we're going to specifically look at the introduction to calculus. Yeah, so we'll start with solving this question on the screen. And this is talking about how we can apply the first principle to differentiate functions and also to find the gradient of any function using the first principle given a point or a set of coordinates. Okay. So the most important thing is to first know what the first principle is, what it states, and even the formula. So the formula for the first principle is, for instance, if you've been given any function f of x, you've been given any function f of x, then you've been told to find or to differentiate f of x with respect to x using the first principle. You say f prime of x, meaning the first derivative, is equal to, you find the limit of f of x plus h. So this h can be any constant, any number. Yeah. So x plus h minus f of x, then everything divided by h as h approaches 0. So this is the principle we're talking about. This is the first principle. Yeah, so let's take one example. I think we'll solve one or two questions from here, and then the other one will remain as an exercise for you to do. Yeah. So I'll start with this one here. So to find this one, to find f prime of x, if f of x in our case is 4x, so if we say f of x is equal to 4x, which is just this question here. To find f prime of x, we're going to say f prime of x is equal to, we're going to find the limit of, the limit as h approaches 0 of f of x plus h. So when we say f of x plus h, we simply just mean that while there is x here, we're going to replace with x plus h. So if, for instance, they ask you to find f of 1, if they ask you to find f of 1 given this function, simply means that while there is x, you are going to replace 1 there, and the answer will be 4. So this is what we are also going to do here. They've asked us to find f of x plus h. So meaning at x, we're going to replace x plus h in this function. So we're going to have 4. While there is x, I'm going to put x plus h. Then I'll say minus f of x. So this f of x is simply just this same function. So I'm just going to write it the way it is. Then I'll divide everything by h. So here what we're going to do is simplify the expression. So we're going to simplify this part. I want to simplify that part. So our f prime of x now become the limit as h approaches 0 of, so we're going to multiply 4 times x there, we're going to get 4x. We multiply 4 times h, we're going to get plus 4h, then we have minus 4x this side. So write that. Then everything divided by h. So 4x, we have this 4x, we also have this other 4x. So say 4x minus 4x, these two give us a 0. So we're just going to remain with 4h on top. So we'll have something like this. F prime of x is equal to the limit as h approaches 0 of 4h over h, which when simplified is going to be f prime of x is equal to, this h will cancel with that h, meaning we're going to have the limit as h approaches 0 of 4. we're just going to remain with 4 here. So the limit of any constant when h or any variable is approaching any number is simply equal to that same constant. So in this case, the limit of 4 as h approaches 0 is simply just going to give us 4. Hence, f prime of x is simply just equal to 4. So talking about the first principle, the most important thing is just knowing how to apply this formula, knowing how to use this formula. That's the most important thing. Otherwise, other things are simple and straightforward. Do you have any questions on this question before we pick another question from you?
I'm clear on this question.
All right, okay. So from here, after finding this, we've been asked to find what? The gradient. Find the gradient of the curve y is equal to f of x. So in other words, they're asking us to find the gradient of y is equal to 4x. So the gradient of this function is simply just f prime of x at the point that we've been given here is 1, 2. So f prime of x is also sometimes known as, okay, not sometimes, it's always known as, or it's also called the gradient function. So f prime of x is called the gradient function. So when you replace this point in f prime of x, you get the gradient of the equation. So we know to say any constant. So this number here can also be written as 4x to the power 0, because we know that x to the power 0 or any number to the power 0, the answer is 1. So 1 times 4 will still remain with 4. So f prime of x is simply just equal to 4x to the power 0. So while there's x here, I'm going to put the coordinate of x there. So this would be f prime of 1. So in this case, we have 1 there. F prime of 1 is simply that now going to be equal to, while there's x there, I'm going to put 1. So this would be 1, but we know to say 1 raised to the power 0 will still be 1. So 1 times 4, the answer will still be 4. So the gradient of this curve, the gradient of this line here at this point 1, 2 is simply just equal to 4. I'm sure you understand this better when you get the other example. Okay, so let me quickly erase. We'll also pick another question. Then I'm going to leave one, which you are going to do as an exercise. Then afterwards, submit. Okay. So okay, so this is the formula. Then I think, which one should I pick? Okay, I'll pick this one. Then you're going to
Let's do the second one.
okay, yeah. So we do the second one, and then you're going to do the last one as an exercise. So f of x is equal to x squared.
No, actually, let's do the last one, and I'll do the second one.
Oh, all right, no problem. So we have 1 over x. Okay. So 1 over x, f of x is equal to 1 over x. And then they want us to find the gradient at this point. So we do the same. So while there's x, I'm just going to replace with x plus h. So to find f prime of x, I'm going to find the limit as h approaches 0 of f of x plus h, meaning while there's x there, I'm going to put x plus h. That's what I'm going to have. Then minus f of x is simply just this same part, which is 1 over x. Then I'll divide everything. So what is x I've replaced with x plus h. Then I'll divide everything by h. So from here, it's just a matter of simplifying the expression. So my f prime of x will now be equal to the limit as h approaches 0 of, when you do the simplifying here, this is just, let me say, we find the common denominator on the numerator there. So the common denominator of x plus h and x is simply just x plus h multiplied by x. That's the common denominator. So when you say x plus h into x plus h times x is simply just x. And then x times 1 there, the answer will be x. Then we say minus x into x times x plus h. The answer will be x plus h. X plus h times 1, we're going to have x plus h. Every time you are replacing, make sure that you are putting everything in brackets. It's very important because imagine if I just wrote x plus h without putting them in brackets. It means that this minus here will only apply to x and not to h. But in this case, we're going to multiply this minus to both x and h. Then we are dividing everything by what? By h. These are square brackets. Okay. So from here now, it's just a matter of simplifying. So we have f prime of x is equal to, so we're going to have x minus x, x minus, before I do that, let me first open the brackets on top there. So I'm going to have, I'm going to have something like this. The limit as h approaches 0. So this will be x minus times x there to be minus x. This minus times h to be minus h. Then I'm going to divide everything by. If you divide this h into everything on top there, you're going to have h, x, and then in brackets you have x plus h. This is what you're going to have. Then this x minus x, we can see that it can they can subtract, and we're going to have a 0 there and remain with negative h as a numerator. So when you simplify this, we're going to have f prime of x is equal to negative, the limit as h approaches 0. We're going to have the limit as h approaches 0 of negative h on top, then divided by, down here, we're just going to remain with h, x, open brackets, h plus h. So this h and that h will cancel. Then we're just going to remain with x, open brackets, x plus h. Rather, we're going to remain with x, yes, on the okay, so our f prime of x will now be equal to the limit as h approaches 0 of negative 1 over x, x plus h. Okay, sorry for the inconvenience. I received the call. Okay. So this is what we're going to have. So here it's just a matter of replacing 0 where there's h. So we're going to have f prime of x is equal to, then you put a 0 where there's h there. We're just going to have negative 1 over x, open brackets, x plus 0. And this will give you negative 1 over x, and then in brackets you just have x, meaning your f prime of x will simply just be equal to negative 1 over x times x here will give us x squared. Okay, so this is how you find the first derivative using the first principle of 1 over x. And then the question goes further to ask us to find the gradient at this point. So from this point, we're just going to use 2, which is the x value, to find the gradient. So to find the gradient, we're just going to replace 2 where there is x here. So f prime of 2 simply just give us negative 1 over 2 and then squared. So this one will just be equal to what? Negative 1 over 4. So negative 1 over 4 is the gradient of this expression at the point 2, 0. Do you have any questions?
No, Sam, clear.
All right. Okay, so you're going to solve this one as an exercise. Okay.
Okay.
So let's move on to the question.